Hi and welcome back. Now in this tutorial I'm going to implement this delete target operation. Now we have actually implemented the delete first and delete last in the last couple of tutorials where we saw how we can delete the first node and the last node of the linked list. Now in this case, the delete target, we actually need to find the target node that contains the target integer value. So for that purpose we need to search across the linked list. If that node exists, then we are going to delete that. Otherwise we are just going to return from the function. So for this purpose we need to use this find operation that we wrote earlier. Now the find operation searches for a target there in the linked list. If the target is found, it returns the address of the target node, and otherwise if the target does not exist, then it returns null. Now we need to modify this find operation, because if you want to delete a node in between the first and the last node, then we need to have the address of the previous node, immediate previous node, in order to delete a particular node, because the next pointer field of the previous node has to be assigned with the address of the next node that you are going to delete. Let me just elaborate this by drawing a linked list image there so that you can understand better. Okay, let us now take this image of linked list and try to understand how we can implement the delete target node operation. We need to find out the node that contains the target integer value, and we need to do that starting from the very first node. We need to apply the search operation that we already did with the find function there in our implementation. So we'll start searching from the very first node whether that node contains the target integer value. Say our target integer is 30. That means we want to delete the node that contains 30. So we'll start searching from the very first node and we'll move ahead, and if we get the target node that contains the 30, then we need to delete that. Now if you want to delete this node, that's our target node, right? We can find it out easily, but just by using a while loop. So if this node has to be deleted, then what we need to do, we need to get the address of the immediate previous node, and the next field of the immediate previous node, that means this node, has to be assigned with the address of the next node that we are going to delete. We are going to delete this one, so the address of the next node is this 4000. That has to be assigned here, so that this next field points to this node and we can delete this. Okay, so what I need is the address of the immediate previous node when we search for the target and when we want to delete that. So if the target contained in the first node, then the operation is straightforward. We can just call the delete first that you already wrote there. So if the target is there in the first node, we'll call the delete first. If the target is there in the last node, we'll just call the delete last. We have already implemented these operations. But if we need to delete a node in between the first and the last node, then we need to have the address of the immediate previous node, so that we can assign the address of the next node that we are going to delete to this next pointer field of the previous node, so that this previous node points to this next. I hope you understand this conception. So we need this address of the previous node that we are going to delete. So while searching in the linked list, we need to modify the find operation there. Our find operation only returns the address of the current node. It doesn't return the address of the previous node, but we need that for this delete purpose. So what we'll be doing, we'll be actually modifying the find operation so that we can get the address of the immediate previous node out of that. So let's see how we can modify the find operation to do that. Okay, the find operation that we wrote so far actually returns the address of the node that contains the target integer value, if the target exists. And if that doesn't exist, then it returns null. Now what we want from this find operation is that apart from the node that contains the target integer value, we want the address of the immediate previous node. Now in C, we cannot return more than one value from a function. We can return at most one value from the function, right? So what we can do in order to get the address of the immediate previous node, we can pass a pointer to pointer there, a node pointer to pointer to the function, and where we can just assign the address of the previous node while we traverse. We'll see how we can do that. Let me just modify the prototype and go ahead and modify the function there. You'll see how we can do that. Okay, so here is our find operation. So what we need is the address of the immediate previous node. So I'm actually receiving a pointer to pointer. This prev ptr is actually the address of a node pointer that is sent here. So the node pointer is itself is a pointer. I will be declaring that in the main function or in the caller. And the address of that node pointer will be sent here as the third parameter. So this has to be declared as pointer to pointer. So star of PVR in these functions. So if I mention this star PVR PTR, then it is actually pointing to the node pointer that we are going to declare in the caller. So we'll be using, so if I assign something here in this star PVR PTR, then actually we are assigning it in the node pointer that we have declared in the caller. I hope that you understand that. I'll draw a picture later on. Let me just go ahead and write the code there, and I'll explain this thing by drawing the picture there. Then you'll understand clearly. Okay, so this find operation has to be modified. What I'm doing, I will keep the address of the previous node always in that PRV PTR. So at the very beginning, when we start the searching, when we are placing the current pointer there to the first node, then we need to assign this star PVR PTR to null, because before the first node we do not have any previous node. So current is starting from the first node and previous to that is nothing. So we are assigning PRV PTR to null. So you can see that star PRV PTR means we are actually assigning this to the node pointer that you have declared in the other function, the caller. Okay, so entering into the while loop, and we are checking whether the current node contains the target. So if that is not, then we need to move the current pointer to the next node. Now, when you are actually jumping to the next node with this operation, you need to assign the address of the current node to that PRV PTR pointer. So star PRV PTR equals current. That means now the previous pointer is actually pointing to the current node, and the current pointer goes to the next node. So when we'll be iterating in this while loop, always this star PVR PTR will point to the immediate previous node. Let me just draw a picture of linked list there and show you how this actually works. So here it is. Let us consider this linked list where there are 4 nodes and head is pointing to the first and tail is pointing to the last, as you can see it there. So we want to find out the node that contains 30. 30 is our target. Now using this find operation, we'll see that how the PRV PTR pointer actually keeps the track of the immediate previous node. So it starts from the first node, current is assigned to the first node there, you can see current is 1000, and what we are doing, we are actually assigning null to this star PVR PTR. So actually when the current is in the first node, we do not have any previous node to that. So star PVR PTR is null, pointing to none actually. So we are starting the loop there, current not equals null, that is correct. We are entering into the loop, current arrow data is 10 and target is 30, that do not match. So we come here, and so what we are doing here, we are assigning the content of current to this star PVR PTR. So the star PVR PTR now gets 1000. So that is going to point to the first node of the linked list, and then we'll be moving the current to the next node. So after this assignment at line 145, star PVR PTR, let me just change the color there. So star PVR PTR is actually here. It is actually a pointer there in the caller. So star PVR PTR is actually pointing to that pointer in the caller. So actual assignment takes place there in the caller function. So it is actually pointing to this first node. It is having 1000 there in it as its content. Now what we are doing, we are moving the current to the next node. So you can see that current will get 2000 because current arrow next is 2000 right now. So that 2000 will be assigned to this current, and current will be actually pointing to the next node. So let me just update that. So current is there at node 2000, and you can see that this star PVR PTR is immediate previous node to this current node. Now again we are iterating back with the while loop there, and of course current is not equals null again, it is 2000. Again we are entering into the while loop and we are checking whether the data is equals with the target. So data this time is 20, that's not 30. So again false, this if is false. Again we are coming here. Now this time star PVR PTR is assigned with current again. So the star PVR PTR now this time is 2000 instead of 1000. So it is updated with 2000. So it will not point to this first node, it will point to this second node. And obviously then we are updating the current moves on to the next node. So you can see that current will have 3000 there, and current will be pointing to this. So the star PVR PTR moves just with the current, but it is actually keeping the track of the immediate previous node of the current node. Again, we are actually iterating back in the while. Current not equals null, that is correct, it's 3000. We are entering into the while loop. Now this time current arrow data is 30 and the target is 30. So that matches, and we are breaking out of the loop. Now we are breaking from the loop. We are just returning the current from the function as the return value, and also the previous node's address is updated there in the caller, because this pointer actually pointing to the variable, the node pointer there in the caller. So it is immediately updated there in the caller. So we don't need to return that, right? So we get the previous node as well as the current node while we traverse the linked list, while we find a target in the linked list by traversing linearly. So that's how we are going to update the find operation. So now we are actually going to write the delete target operation, and we'll be using this find operation there, and we'll see how we can use this there in the delete target node. So let's go ahead and implement that delete target now. Okay, before I could go ahead and write that delete a target node operation, I would like to attach this find operation that we have just modified there with the switch case, so that we can just call and check that find operation, whether that works perfectly or not. So for this purpose, I need to declare two pointers there. As I have done that, here you can see that pointer current and pointer previous. This current pointer is going to get the address of the current target node, and this previous prev is going to get the address of the immediate previous node. So initially both of these are assigned with null. Okay, so it's option 7, so we are going to go there to case 7 there. I have not implemented that earlier when I wrote that find, so I have modified that now, and I can just call that. So I'll just ask the user to input the target, and we'll scan that target from the user. %d, we can use that data variable in order to keep the target there. And now what I'm doing, I'm just calling that find operation. So you can see the call there, how we can do that. So here, the first is the address of the list object. Second is the target that we need to find. And the third is important. That's the address of the node pointer, where we are going to get the address of the immediate previous node. So this amp previous is actually the address of the node pointer previous. Since prev is a node pointer, so address to that is a pointer to pointer. That's why we used that node pointer to pointer there in the function find. So that PRVPTR in the function find is actually pointing to this PREV, this particular pointer here in the main. So whatever we are assigning through that PRVPTR from that function find will be actually assigned immediately here in this pointer field, in this node pointer field PREV. Okay, so we'll get that previous node's address in this pointer PREV, and if current is null, obviously the target does not exist, so we need to print a message there. Otherwise, if the target is found, we can just print that. Let me just print the address of the target node as well as the previous node. So you can just do that by printing the content of current and PREV. We'll see how that works. So let me just go ahead and run this and check whether the prev and the current contains the exact values of the immediate previous and the current node that contains the target. So let's go ahead and run this. Okay, so here we go. I'm inside the folder where I have kept that linklist.c. So let me just compile gcc linklist.c. Okay, it's done. Now I can just run that. Oops, sorry for that. So we get the menu. So now I'm going to load the data from the file and create the linked list. Option 1, file has been loaded. Now we can just print the details there. Okay, so you can see that we can get the address of each node and the next node. I have explained this function earlier. So now I'll just try to find something there in the linked list. Say I want to find out if any node contains 25. So option 7, find, yes, 25. Now you can see that target node exists. Address of the target node is this one. You can just match this with the previous display. The last is 040 there, and the node that contains 25 is obviously, this is the address that exactly matches. Now let us check whether the previous is correct or not. Previous is 0x7fb1, then we have the rest of the thing here. Last is 0030. So the immediate to that, yes, it's exactly the address here, that is the address of the node that contains 500. That's the immediate previous node. So you can see that we can get the address of the immediate previous node using that modified find operation. So it is working fine. So I'll just exit from this and we'll go ahead and write the delete target node operation now. So you're all set to do that. So let's now go ahead and implement this delete target. So here it is. Now we need to write this. Okay, so what we need to do is to call the find operation at the very beginning, at the very first of this. So let's do that. And we need 2 pointers there. One is to hold the address of the target node, and other is to hold the address of the immediate previous node, as we saw earlier while we called that find operation from the main. And we'll be assigning these two with null at the very beginning. So now I'm going to call that find current equals find, and we'll be passing this lstptr, that's the address of the list object. The second is the target that we want to find. The third is the address of the pointer, node pointer, that's going to contain the immediate previous node's address. So if current is null, then obviously we do not have the node there. So I'm just returning an absurd value to the caller. We cannot delete the node because the target does not exist. Otherwise, the target exists. Now there are 3 different possibilities. The target could be the first node, it could be the last node, or it could be any node in between. So we need to check that. If current is lstptr arrowhead, that means the target is the first node, then we just can call the delete first operation, right? And that will delete the first node. We do not need to do anything else, just but to call this delete first. Okay, so we'll be passing this lstptr, and that will be deleted. And whatever we get from the delete first, that's the content of the first node, we need to return that back to the caller, and we are done. Else if the current is last node, lstptr arrow tail, then we just need to call the delete last operation. So I'm calling that delete last, and we need to pass on that lstptr there. Whatever that delete last returns, we need to return that back to the caller. Otherwise, we need to delete the node in between the first node and the last node. Here we are going to use that previous pointer, right? So the next pointer field of the immediate previous node that we are going to delete has to be assigned with the address of the next node of this target node. So the prev arrow next, that has to be updated with the current arrow next. In this case, we need to just free this current node, and then we need to decrement the node count. So lstptr arrow node count minus minus. We do not need to decrement that node count or free the current node there for the other cases, because in case of delete first or delete last, we did that in those functions. So we are done with this, I think. And at the end, what we need to do is to return that data of the current node that we need to keep there. Okay, so here we go. We need to keep the data there, and we need to return that data. So I will declare that. So here integer data equals current arrow data. We get the data out of there. So in this case, we can return the data from here. So all the cases are done now. So let me just explain once more this else part there using a figure. Okay, here you go. Say we need to delete this node that is at address 3000. So this is our current pointer that contains 3000 right now. After the search operation, find operation, we get this current pointer from there. And the prev is actually pointing to this previous node that is actually 2000. So we want to delete this node at 3000. So this has to be deleted. So what we are doing here, we come to this else part and prev arrow next, that means we are actually updating this. You can see that what we are assigning there, current arrow next. Now the node that we are going to delete contains the address of the next node. So that is 4000. Current arrow next is 4000. That is assigned there in the prev arrow next here. So this next field of the previous node is now going to point to this, and we are free to just remove this. So while we traverse the linked list now, after this delete operation, after this node will get this node. Okay, let us now go ahead and try to compile and run this program. We'll check whether the delete target works fine or not. I have added that call here under case 10 because it was at menu option 10 there. So it's just as usual. So let's go ahead and compile that. GCC link.c, linklist.c, yeah, that's compiled successfully. We get the menu. I'll use option 2 to create the linked list this time. So I will use 10 numbers. Okay, so the linked list has been created with the random numbers. There should be 10 nodes. Okay, let's see. I'm using option 5 to display, okay, option 6 to display the nodes there. Yeah, these are the nodes that are there. Now I want to delete a target node. Say I want to delete that 767. So I'm using that option 10 to delete a target node 767. And it's saying that the target with node with data 767 deleted successfully. Let me just display the linked list once more so that we can get the details now. You can see that the 767 does not exist anymore. Let me just do that once more with some data that is not existing in the linked list. So I'll be using 10 and say I'm giving 1001 that doesn't exist. So it's saying that 1001 does not exist in the list. So it's working fine. So you can check with the terminal values, that means the content of the first node and the last node as well. So they will work fine because we have tested those delete first and delete last earlier, and we have called those operations from the delete operation that we have just written. So they will work fine as well. Okay, so we have done with this delete operation. It was a long tutorial, I understand that. Now in the next tutorial, we are going to implement the reverse operation, the reverse linked list operation. That is another interesting operation that we are going to implement. Okay, now let us just make a note here. This delete operation is dependent on the number of nodes in the linked list. That means the time of this delete operation will obviously depend on the number of nodes in the linked list. You see that we have a while loop there in order to search the target node in the linked list. So if the number of node increases, that will increase the time of this operation as well. So in the worst case, the target node could be the second last node or the last node or almost there at the end of the linked list. In all such situations, we'll traverse through the entire linked list to get the address of the target node there. So we say that in the worst case, this algorithm delete target node depends on the number of nodes of the linked list. If that increases, obviously the time will increase to perform this operation. So thank you very much, and join me in the next tutorial to implement the reverse operation.